So today's video is on characteristics of exponential functions. So for this, the important information is the parent function is a b to the x power. And we're going to be dealing with this over the next several days. But just know that's the parent function. So there are several characteristics of exponential functions. The first one is that the domain is always negative infinity to positive infinity. So that means the graph is going left and right forever. It's not going to stop. The range is either negative infinity to the asymptote, which we'll talk about, or the asymptote to infinity. So we'll learn that the asymptote k is sometimes there's plus a number at the end up here, and that's going to be your asymptote. And when we start graphing, we'll give you a little cheat sheet. So number 3 talks about the asymptote that we just talked about in number 2. The asymptote is always the k, which is the vertical shift. So a number at the end, you have a graph, and then it's going up and down. That's the k value. Next is there will always be an interval of increase or decrease, but never both. So you'll have an interval of increase or decrease, but never both. So it's either going to go up or down. And then finally, you can determine the average rate of change between any 2 points on the graph using this formula. So that's your slope formula. So your average rate of change is AROC, but that stands for average rate of change. So for this, it's similar to when we did our linear functions. When we found our average rate of change, your slope. This case, though, it's not a line, like a straight line. So that's why it's called average and not slope, because you're averaging the 2 points together. And finally, number 6 is the end behavior. The end behavior is where the x values is what the x values do as x approaches the left and as x approaches the right. So that's looking at your arrows. Let's go ahead and look at an example. Okay, so let's look at number 1. It says, given the graph of an exponential function, list all the key features. So based on the base, which we don't have the function written for this graph, which is okay, but the base is going to tell us growth or decay. In this case, we're looking at the graph and thinking, okay, if I'm a little person walking on this, I'm going to walk uphill, so it's growth. We already said the domain is left and right, and this graph goes left and right forever, so it's going to stay the same. Negative infinity to positive infinity. Next, we have the asymptote. So that's where this graph is flattening out. So if I'm looking at this, it's getting flat where my little man is walking. So your asymptote is actually right there on your graph, and it has to be a dashed line. So your asymptote is where it's approaching. And you cannot touch or cross the asymptote actually. So on this one, the graph, my invisible line is on 4. It's going through the y-axis, so my asymptote is going to be y equals 4. Your range deals with your y values. Your range are your y's, just like your domain are the x's. So my range, you go bottom to top. So in this case, I have a bottom of my graph. The bottom is the asymptote, and there is no top. So bottom is 4. Top goes up forever, so top is infinity. You can never touch infinity, so it gets a parenthesis. And in this case, 4 is the asymptote we just labeled above, so 4 also gets a parenthesis. Your y-intercept is where it crosses the y-axis. So right here is your y-intercept, 0, -3. And then next I want the x-intercept. You won't always have one, but in this case we do. It's where it crosses your x-axis. So it's right here. And it gives you the point already. It's 2, 0. Next, if we remember from above, it says you're either going to be increasing or decreasing. And we already said it was growth, which means it's going to be an interval of decrease. So the interval of decrease, and it's not going to have an interval of decrease then. So none for decrease because it's growth, which means it's increasing. And just like before, it's increasing the whole time. It doesn't switch directions. So -infinity to infinity is how we represent the whole time. Okay, next we have end behavior. So remember, end behavior is just looking at your arrows. So I have 2 arrows on here. As x approaches -infinity, so remember, you're thinking just about the x-axis. So on a number line, -infinity is the left side. And as I look on the left side, the graph was flattening out. So because it's flattening out, right here is my left side, and it's on the asymptote, so it's on 4. As x approaches infinity, that's looking on the right side of the graph, so that's right here. The function's going up, so it's infinity. With all of these, you're going to have an infinity and an asymptote. It's either going to be or a -infinity and your asymptote, but there's only going to ever be one infinity. Scroll down a little bit. The last piece we have is average rate of change. That's your slope. And when you're given these, it says 0 is less than or equal to x, less than or equal to 2. So these are your 2 x values. So I have 2 points I need to find slope. Each of these are the x's. So I have 0, some number, and 2, some number. Well, I need to know the y value, so I'm going to look at my graph above. So 0 is at -3. 2 is up here and says 2, 0. So that's x1, y1, x2, y2. And then we're using this formula, which is above. And remember, you don't have to memorize this formula. It's given to you on the end of course test. So let's go ahead and fill in the numbers we have. So y2 is 0, minus, remember it's always minus, y1 is a -3, divided by x2 is 2, minus x1 is 0. Don't forget, these 2 negatives make a positive. So 0 plus 3 is 3. 2 minus 0 is 2. So your slope for this problem, or your average rate of change, means the same thing, is 3/2. Okay, we have one more problem on the back. go ahead and switch to the next video for the back problem. You need this for your homework, so make sure you're watching both videos.